our third task, which is the DC motor. So we need to control a DC motor with Arduino, and there will be a motor driver L298N. So first of all, why do we need motor driver? Among many other reasons. First of all, the Arduino operating voltage is like, let's say 5 volt, or for some boards it is 3.3 volt, and also the currents that Arduino provides in its output pins are very much low as compared to the motor operation. But the motor can take 12 volt, or let's say some motor can take up to 30 volt as well. So the motor take high voltage, and also you know that the motor generally takes high currents as well. So you need to provide high voltage and high currents in motor, but Arduino generally operates at lower voltage and lower current as compared to motor portion. That's why you need some sort of other devices or other portions to provide that high voltages, comparatively high voltages and comparatively high currents as well. So that's why we need motor connection. And another main reason I can say that you need to control the motor operation. Let's say you need to sense the direction of rotation. First of all, you are rotating it clockwise, then you want to rotate it anti-clockwise, then also you need the motor driver. And also if you need to reduce the speed of rotation, then also motor driver will be good choice. And we will be using L298N motor driver. So here we can connect two motors, so one motor in out 1 and out 2, and another in out 3 and out 4. So you can connect two motors, and this motor driver can operate two motors simultaneously. So in this experiment we will be demonstrating one motor connection, and these are the power pins. So first of all, this 12 volt, that means what amount of power you want to provide for the motor. So an ideal choice, let's say 12 volt, we are operating 12 volt motor, that's why we will be providing 12 volt motor, 12 volt power supply in this portion. And then this ground pin, where we will be connecting our ground, and the third pin is the plus 5 volt. So we will supply plus 5 volt here. Now you may ask why we are using two types of voltage supply. So this plus 12 volt will be using for this motor voltage supplies, because motors generally operate at higher voltages. But there are logical portions here as well. We will send a logical signal to this board from Arduino. That's why we need the logical voltage. That's why this 5 volt is the logical input. So I just demonstrate the power portions. The other portions, if you notice here, enable A, enable B. So these two enable pin is basically enabling this output pin. So if you provide 5 volt to this enable A, this output 1 and output 2 will be activated. That means if the motor is connected to out 1 and out 2, the motor will be able to rotate. But if you provide a ground supply to this, then the motor won't operate. Similarly, this enable B to motor B. So you can give positive 5 supply constantly here, or also there is another good choice, which will be the PWM signal. So in first experiment probably I have demonstrated PWM signal, that means pulse width modulation. So there are different duty cycles. Let's say if this is a 50% duty cycle, that means 50% time it will be high and 50% time it will be low. So you are basically changing the intensity of the signal. So you can send this PWM signal to these enable pins, and since you can understand if it is 50% PWM signal, then intensity will be half when it was 100% duty cycle. That's why you are reducing the intensity, and this reduction will reduce the speed. So if you want to control the speed of the motor, then obviously this PWM signal should be used, and you can use this in this enable A for motor A operation, and similarly enable B for motor B operation. So we will be using PWM pin of Arduino, and we will connect those pin in enable A for motor A operation. And these other pins, that is input 1, input 2, input 3, input 4, these are for a logical input connection, and these are constant and digital pins you can connect here. So input 1 and input 2 for out 1 and out 2, and input 3 and input 4 for out 3 and out 4. So what this will do, for input 1 and input 2, first of all let me clear this all. So let's say this one is the input 1 and this one is the input 2. So you may provide a high value here and low value here. So motor will rotate to clockwise direction, let's say, and then if you change it to low here and high here, then motor will operate to anti-clockwise. And if you provide both low or both high, then motor will be stopped. So this type of combination you can provide, and then by this combination you are generally controlling the motor. So if you want to rotate it clockwise, you can provide high and low to I1 and I2 respectively for motor A. So that's why we will be using digital pins in I1 and I2 for motor A operation. So I think this H-bridge motor driver, I just demonstrated all portions. So let's move on. So this is the circuit diagram. First of all, I just demonstrated that we will be using this in1 and in2 to digital pins, and obviously this enable A, ENA, you should use this as a PWM pin. And what are the PWM pins? If you notice here, there is a tilde sign, and this sign denotes that that pin has PWM capability. So you can use those pins, those have that tilde sign in front of them. So you can use pin number 9 that I demonstrated here, and this powering portion you can supply 12 volt using DC. I will be demonstrating this when I demonstrate in Proteus. And then a ground connection, and this is just the 5 volt connection, and this motor is connected just like this. And also in this simulation we have these 2 pins here, and we don't need to connect them in ground. This portion is basically available in basically available in Proteus. That's why we just need to connect them, but in actual L298 board these pins aren't available, so don't worry about them. Down here we have also used a potentiometer to control the motor operation. So through this potentiometer we will be reading some values, and then we will convert that value to PWM signal to provide in our pin number 9, that is enable input, so that we are basically controlling the motor speed using this potentiometer. So whenever this potentiometer will be, let's say, 100%, then the motor will rotate at its highest speed, and whenever it will be very much low, let's say 0%, then it will be rotate at its lowest speed, and if you provide it 0%, then motor will be stopped. So this is the circuits. One more thing, this is a push button connection. So in this push button there basically we will be using 2 configurations for motor clockwise operation and motor anti-clockwise rotation. So when you press on this push button, you can understand that this pin number 4 is directly connected to this 5 volt. That means pin 4 is having a high signal. So when you press that push button, that means whenever it is on, you are giving on to pin number 4. So again, if you press it, if the state is 0, that means if it is unpressed just like this, then this pin number 4 is basically connected to ground. That means pin 4 is having a 0 connection. So by combination of these 2 configuration, you can have on or 0 to this pin number 4. And in the code we will be writing that whenever we have a 1 in this pin number 4, then we will rotate the motor in clockwise direction, and whenever we will have a 0 in that pin, we will be rotating our motor in anti-clockwise direction. Okay, I forget to insert the code here, so I will be demonstrating that code whenever I will be demonstrating the simulation. So that's all till now. I will be demonstrating the simulation, so stay with me.